Hi everyone, Audro here. In this episode, I speak with Jenny Reed, who's a program director at the Advanced Research and Innovation Agency, or ARIA for short. ARIA is a new initiative by the UK to fund work and research that's not getting enough funding, but could be really impactful in the long term. They're loosely modeled on the US's Defense Advanced Research Projects Agency, or DARPA, but without the defense angle. As a program director, Jenny has carved out an area that she thinks is ripe for investment, and you guessed it, it's in robotics, mostly around manipulation. To me, this kind of initiative is very exciting because it might bust some plateaus we're seeing in robotics and let us get to some new applications and markets. I think you'll like this interview if you're into far-sighted technologies that could make a big difference, or want to understand some of the challenges and opportunities in the current state of robotics. Also, if you're interested in doing some of this far-sighted work, ARIA is in the UK, but is not just for people in the UK, so you might consider applying. All right, with that, let's get to the interview. Hi, Jenny. Would you introduce yourself?
Absolutely. I'm Jenny Reed. I'm a Programme Director at ARIA, the UK's Advanced Research and Invention Agency.
And tell me about ARIA.
Yeah, ARIA is quite a new funding organisation in the UK. We were founded by an Act of Parliament in January 2023, and our mission is to produce transformative societal benefit through science and technology. So we're a kind of new, it's an experiment, basically, in a new way of funding for the UK. We're loosely modelled on the ARPA and DARPA model in the US that is widely perceived as having been very successful. And we haven't really had that kind of programme-driven, mission-focused approach to funding in the UK before. And that's what ARIA is trying to kick off.
Mm-hmm. Now, you say loosely focused. What aspects are you taking and what aspects are you leaving from the ARPA-DARPA program?
Yeah, well, one important thing that we're leaving from DARPA is the defence aspect. So defence.
Just ARPA, no D.
Exactly. Okay. Defence and military is actually the one area that ARIA won't fund. So that's an important change. And that has various consequences as well. So, DARPA has a sort of built-in customer in the form of the Department of Defence. ARIA doesn't. So we have to think hard about how are we going to take the science and tech that we deliver or develop and translate that into societal impact.
Mm-hmm. And so, it's about tech transfer, basically. So you're funding research so that it can, you can build companies out of it and it can improve society in general.
That's right. So it's an interesting mix because we are not translational in the sense of being super high TRL or close to commercialization. We can fund very low TRL.
What's TRL?
Sorry, technology readiness level. I'm being too jargon.
Oh, I would never know that acronym. Okay. Yeah.
Yeah. All right. So we fund work that's very basic and speculative, but importantly, we always have a sense of how we're hoping it's going to deliver benefit for society. So we wouldn't fund, or we haven't typically funded work that's sort of blue sky in the sense that we have no idea how this might benefit. We have a purpose in mind, and then we're trying to get the knowledge and the technology together that we need to solve the problem we're focusing on. And we have, at the moment, 7 programs, and each program is focusing on a different problem area or challenge that we're aiming to solve.
Okay, very interesting. Now, would you tell me a bit of your role in all of this, and then I guess specifically about the Robotics Focus?
Absolutely. So I'm a program director, which is ARIA's version of the ARPA program managers. And that's an interesting part of our model, actually. So one of ARIA's principles is we always say we fund people, then projects, rather than focusing on the project first. And ARIA applied that approach by starting out not thinking like, here's a particular area of science or a particular challenge that we want to solve, but rather let's recruit the program directors. So they started out and they recruited 8 program directors like myself. And then each of us was given the challenge of try and find what ARIA calls an opportunity space. So an area which feels really important. There's something that, if true, would be hugely important for society, but it's also underserved. So it hasn't received the attention and resources commensurate with its potential importance. And it should also be in some sense ripe. So there's a reason why now is the time to dive into that space.
Tell me more about that underserved part of it, because that's an interesting thing I remember from our previous conversation.
Yeah, that's right. I think we're trying to shift the dial, and we're trying to find new spaces. We don't want to jump on a bandwagon where there's already lots of attention, because, that's great, it's being dealt with. So we wouldn't have much counterfactual impact there. So we're trying to find things that are currently neglected because nobody else will do them for whatever reason, whether it's because it's too risky or it's not the sort of thing where it's easy to capture value, so it's not a attractive investment proposition. And so for all those reasons, that particular space is underserved and yet potentially hugely valuable to society.
So you're not going into areas that are receiving a ton of investment from, maybe it's like American venture capital or something like this. And you're focusing on areas that they're missing that are also probably high impact and for one reason or another are not getting funded.
Exactly.
Correct? And there's probably also, you leave a little bit of like the hype space, because certain areas really blow up and the investors pay unbelievable amounts of money for it. And then it's like you won't make much of a contribution there. So you're focusing on really high impact, potentially, or preferably ignored areas.
That's right. Where can we change the conversation?
Okay. And so where in robotics are you focusing?
Yeah. So when I came into ARIA and started looking around in robotics, very much as an outsider, my background's actually originally in physics and then for many years in neuroscience. It's quickly dawned on me that obviously robotics is having a bit of a moment. There's so much potential with AI. And so in lots of robotics, I feel it's exactly like you say, there's not a lot of space for ARIA to make a difference. But it felt to me like there was one area that was being relatively neglected, and that's hardware. So I
agree with that, yeah.
Good. Yeah, I was very struck, as I say, as an outsider to the field, by how little robot hardware had advanced really over the past sort of 50 years or even longer. And people are saying to me, well, that's because we know the bottleneck is the control and the autonomy, right? You can teleoperate existing robots to carry out complex tasks, but we can't yet have them do those same tasks autonomously. So that proves that the problem is the control and the autonomy and not the hardware. And I think that has been true, but I doubt it's going to be true. Yeah, it's arguable, but I think it's been, certainly a compelling case can be made up till now, I think. But my sense is that over the next few years, precisely because of this explosion in novel AI techniques, that's going to cease to be true. And there's going to be a new bottleneck, which is the capability of the robot bodies. And again, coming from neuroscience and spending my time studying biological brains and bodies, it was very striking just how crude current robots are compared to our own bodies.
Yeah, simple heuristics get us a long way in robotics. So it's like, pretty crude. A lot of things, they just kind of work and pretty robustly. Okay, so hardware. Where within hardware? Is it hardware in general? Is it manufacturing? Like, what are you thinking within the hardware space?
There's a few areas that I'm concentrating on. So one is actuation. So I feel like at the moment, robotics is largely using DC electric motors. That's a very mature technology, but it's a very old technology at this point. It's nearly 200 years old. And and it obviously wasn't designed for robotics. And in many ways, DC electric motors are not suitable for robotics, right? They typically generate low torque.
I don't know too much.
Yeah, low torque, high frequency motion, whereas what you would typically want in robotics is high torque and much lower frequency motion. So then,
you're saying like drone motors aren't appropriate for like, I don't know, robot arms or something like this, where they spin at a very high speed, low torque. Yeah, these kinds of things. Totally agree.
Right. And so then you need gears, right, to translate that into a high torque, low speed
and then
motion.
Big reflected inertia and all sorts of problems there.
Exactly. You've got all this inertia that you didn't want. You're just basically fighting all the way down against the problems caused by the fact that the technology fundamentally isn't suited for the needs.
Well, the high gear ratio ones, I mean, there are low gear ratio ones that I think are better. Do you think so? Or like the ones, there's some companies where they're doing like 1-to-1 or 1-to-4 gear ratios. And so it's very direct. It's high torque. I think. I'm not too knowledgeable in this area, but what do you think?
Yeah, I think there are a number of different solutions, but none of them are ideal. They all have problems like efficiency and weight and backdrivability. And, when you compare it to biological muscle, that
Very different.
Yeah, very different, right? And so one of the things I'm interested in and trying to develop in the program is fund novel forms of actuation.
Oh, okay. All right. Actuation sounds really cool. I think I'd like to go through all of the different areas in hardware that you'd like to focus and then maybe circle back to them in more detail, because I have more questions definitely for actuation, but I don't want to get bogged down there right now. I want to see the whole thing.
Yeah. So another one is sensing. So again, I was struck by the relative crudity and poverty of robot senses, apart from vision. So typically robots are equipped with cameras. I'm a vision scientist, so you don't need to convince me about the benefits of vision. And we are highly visual creatures, right? And one of the consequences of that is that we've invented painting and photography, and we love looking at pictures. So cameras are ubiquitous, so they're small and cheap and available to use in robots. But if you were designing a robot a priori, I don't think you'd necessarily start with cameras as top priority. And the reason I say that is if you look at biology, there are animals that cope without vision at all, right? Cave salamanders with no eyes and so on. But I don't think there's a single animal that that lacks touch sense. The kind of sensation is clearly super important in biology. And it's not like I'm obsessed with robots having to copy biology, but evolution has been exploring the design space for billions of years. And apparently it hasn't found any workable part of that design space that doesn't have really rich tactile sensing.
So sensing, and specifically touch sensing, is what you're interested in. I think that's really cool. I mean, if we had robots with skin, all of the sensor information you could get would be amazing. In having the robot navigate the world and operate without pushing things over and whatever else.
Right. And the other thing, of course, is sensing about its internal state as well, because that's the other thing that surprised me when I entered the robotics field, was to learn about how fragile robots are. I remember visiting a lab and they were showing me a robot that they were trying to train to do household cleaning tasks, but the lab chief was like, but I mustn't touch it because I'll probably break it. It's that fragile. And I was like, hang on, could this be a problem? And I think presumably one of the reasons robots are fragile is that they lack sensing about their internal state or nociception. So they don't sense when they're doing themselves damage. So they're a little bit like these humans who have some, genetic disorder, which means they don't feel pain. And they have to live really careful lives because otherwise they die incredibly young because of all the damage they've done to their body without realizing.
Oh, for sure. Or if you lose nerves in your feet and then you have a pebble in your shoe, and that really, the infection and wounds that you can get there.
Exactly.
Okay. So I like those points quite a bit. So sensing, so actuation, specifically around motors, or not novel sensing, novel forms of actuation, and then sensing around touch and proprioception. Is that what it's called? Yeah.
Well, there's proprioception and nociception. So proprioception is sensing your current state of your body, and nociception is sensing when it's being damaged, essentially.
Oh, cool. I didn't know that word. Sweet.
Yeah.
Any other focus areas?
Yeah. So the other area that we're giving quite a lot of attention to, and again, coming back to this idea of evolution, one of the things that again struck me about robotics is how little attention has been given to things like morphological computing, the advantages you can get by making control more efficient by designing the body appropriately. And that's, again, something that I think we see very commonly in biology. And it's because in evolution, brains and bodies obviously evolve together in lockstep. Whereas my sense is that in robotics, often you get a mechanical engineer designing a robot, choosing the actuators, choosing the limb lengths and so on. And then they sort of hand it over to a computer scientist or a software engineer and go, okay, figure out how to control this thing. And it's almost a bit like, it reminded me of the Frankenstein movie, you've got this body and it's like, bring it to life.
Yeah.
And then looking back, even I realised actually the earliest I can trace this back in sort of Western tradition is basically the book of Genesis, right? God forms man from clay and then breathes life in. And obviously that's not at all how we think of evolution having happened. And I think that's the tight integration between the neural control and bodies in evolution is why we see this incredible efficiency. So that's how you can get something like a bee with like 1 million neurons doing all these amazing complex things, right? Yeah. Flight, obviously, but all these sort of decisions and memory and communication, like in which direction is the best honey and so on. And I think part of the reason they're able to do that is they just need to spend so many fewer computational resources compensating for the inadequacies of their bodies.
Yeah, they're just driven by impulses, in a sense, that are highly efficient and very appropriate generally to their environment.
Right, exactly. So when I see people saying, oh, well, look, the hardware is fine because, I can teleoperate a robot to do this. You're kind of like, well, yes, you can, but you're throwing an entire human brain at that problem, right? And a human brain is a lot of computational resource power, and what you're achieving could be done by a mouse brain, if that mouse brain is deeply integrated into a mouse body. So can we find ways of achieving that kind of efficiency gain in robotics? I mean, people have looked at this, right? Because obviously you can't actually evolve robots. Like, one, they don't reproduce, and two, we haven't got billions of years to play around with. So you have to do it in simulation. And people have obviously tried to explore similar ideas. But I think up till now, you just haven't been able to simulate things of sufficient complexity to really make any progress. And that's why, up till now, actually the best deal was to have a smart mechanical engineer design your robot body. But maybe we're reaching the point now where that's no longer true. And maybe we can experiment with generative AI, exploring in simulated worlds. Suppose this control strategy gets integrated with this particular body design. Can we discover unexpected efficiencies?
Yeah, that kind of thing is really cool. Yeah, I remember several years ago looking into work like this, and it's super cool. And in theory, it's amazing. I just haven't seen that compelling of examples recently, but I haven't been in the academic space for quite a while. So maybe that kind of thing has happened. Or the results that you achieve might be amazing in simulation, but they're very hard to generalize to reality because they overfit the simulator, and the simulator has all sorts of shorthands for complex physics phenomenon.
Right, exactly. So clearly a big part of this effort is going to be improving our physics-based simulation and developing techniques for closing the sim-to-real gap, for sure.
Yeah, very cool. Okay. Do you have any more focus? Because that already seems like a lot to me.
Yeah, that pretty much covers it. But you're right, it's a lot.
Okay, so I hear novel actuation, sensing that's around like touch sensing, and then also like state sensing where they're like, am I in pain or something like that, so they can realize their state. And not the word for it, but then morphological computing, which you said, and that's like a tighter integration between hardware design and control strategy, probably with a lot of leaning on simulation. Is that right?
Correct. Yeah. I should say even though nociception and proprioception, I think, are important, we're not funding any work in that area just based on what was...
Yeah, that seems very hard to me. Yeah. But I don't know the technology state in that area too.
Right.
Okay.
Well, proprioception, I think proprioception does come in with some of the novel artificial muscles, which can report on their own state effectively.
Yeah. And if you have encoders and motors, you can tell where the arm is and things like that. So we have proprioception, or however you say it, to a decent level, but we don't know if like you don't have skin, so you can't tell if you're bumping things, and a lot of it's more open loop. And you can observe at the motors if they're bumping things because you'll generate a force on them, and they can observe that. But it's still not as good, and especially with the high gear ratios, you might clobber stuff before you realize that you have indeed clobbered it.
Right.
Okay, so tell me about. So I get the areas you're focusing. That's really awesome. Your background in neuroscience and biology, tell me how you're here and how you are, I guess I'd love to hear your background and how you got involved with all this. And you mentioned they were funding people, not programs per se. Tell me how you started with all this.
Yeah. So as I mentioned, I started out in physics. I actually did a doctorate in theoretical astrophysics. But after that, I moved into computational neuroscience. I started modelling synaptic transmission, and then I got into vision science. And I spent many years studying stereoscopic vision. So how you get a sense of depth by combining the images in your two eyes, it sounds kind of niche, but it's actually a really nice model system for studying perception and understand it. Yeah, right. How is this?
Robotics, it's like we use it all the time. Stereo vision for depth. Cheap cameras, you just need processing, and you can get a lot of information, very rich information about the world.
Right. Exactly. And it's a very nice question for perception as well. Like, how is it that electrical activity in neurons can give you a sense of depth? So I was studying stereoscopic vision in humans and other primates for many years. And then my career took a bit of a swerve because I discovered that insects have got stereopsis. Just through a chance conversation in the coffee room, a colleague was mentioning to me that praying mantids have got stereoscopic vision. And that was news to me at the time, and it really surprised me because within the field there's a sense that stereoscopic vision is something really complex.
Computationally expensive.
Exactly, right. You're trying to solve the correspondence problem.
And their little head in the praying mantis has the stereoscopic vision.
Exactly. I'm like, wait, hang on. Insects got a stereoscopic vision. So I applied for funding to study insect stereopsis to understand, like, how are they doing this? Is it similar to human stereoscopic vision, or is it different? Long story short, it's kind of both similar and different. That was a really interesting research program. But it also got me thinking about robotics for the first time. And I think that's because insects are so simple, it's kind of natural to think of them as little robots. So I started thinking, yeah, right. So I was trying to reproduce whatever stereo algorithm is going on in the head of the praying mantis, but then
that's really cool. Yeah, I see how that lends to robotics.
That's right. You start to have to think about the motor behavior as well, because one of the things that is clear is that their stereo vision, I think, works best in the center of their vision. So, they have to detect something and then move their head towards it. So now you really have to focus. You have to close the loop, right? You have to put the motor behavior in when you're thinking about the sensory input. So, I was thinking about robotics from that perspective. And so then when ARIA came along and, recruited for program directors and made it clear that you could apply to work on something that was outside your existing area of expertise, I just thought, well, it's probably crazy, but why don't I pitch to them to come and do something on robotics?
Very cool. Okay. And then, so how does this all, so you have your focus areas. How do you go about selecting like, what were you looking for? How much funding and support are these companies or groups getting? How does all this work kind of from a logistics of the program perspective?
Yeah, so the first thing to say is it varies a lot from program to program because program directors have quite a lot of freedom to set things up how they think is best going to advance their particular program.
I guess now, how are you doing it in this case?
So in my case, I had a budget of around £50 million. In my original call for proposals, I said, the maximum for any individual project was 20 million. Actually, I'm not planning to make any such large awards. I've probably made more smaller awards than, fewer larger ones. The other thing about my program is extremely collaborative. So a lot of the creators, as we call them, the people who are actually going to be doing the research, are, even if they applied separately, going to work with each other. And that's something that I certainly feel very positive about, but I was struck by what an appetite there was from the community for that. And I think that's one of the things that attracts me about ARIA, the idea of sort of synergy and, the whole being more of the sum of the parts, because you can work together collectively on this common goal. And the co-design area that I mentioned, where you're trying to co-optimize the design of a body and also the control, that's a great area where I have a whole bunch of different creators bringing particular skills in areas like probabilistic programming or closing a sim-to-real gap or Bayesian optimization or the nitty-gritty of actually building robot hardware. So they're all coming together with these different lenses and perspectives. And I think that's going to be super helpful.
Yeah, I think so too. Well, that's really cool. When you're saying that they work together, are they working together inside of your program or across the whole ARIA program? Is it like, go ahead.
It's within a program.
Mhm.
So they're working together
And
within
so
my
maybe
program.
like sharing code, sharing resources, sharing know-how, all towards the advancement of all the goals that
That's
you
right.
are. Ah, okay. I
Exactly.
like that a lot.
I like that. I should say it's not mandatory. So there are some creators within the program who, maybe they're a company and they don't want to share anything because of their, commercialization goals. That's fine too. But I'm happy that there are many creators who are very open about sharing code, sharing ideas, sharing approaches.
Oh, yeah. I mean, especially I think when you go deal with problems that are as hard as these, there ends up being a lot of boilerplate. Like there ends up being a lot of things that are undifferentiated and don't allow you to test your idea, or like they're just necessary steps on the way there, and like might as well share all those.
100%.
So you have companies and research labs, or like who are the people that are applying for some chunk of your 50 million pounds?
Yeah, all of the above. So we're very open as to who we fund. Big companies, small companies, academic research labs, even individuals.
Wow.
Everyone's eligible. We can also fund outside the UK if we think that'll benefit a programme. So, yeah, and in my case as well. I don't think I've actually ended up selecting any individuals to be funded as part of the programme, but apart from that, pretty much every other type of entity.
That's cool. So you mentioned you can fund people outside of the UK. Actually, before we get into that, where are you guys now in the process? Like, do we have, I think you were saying before that you have a few people, or you have groups, but you're finishing up negotiating, or where are you now?
That's right. We haven't yet signed any contracts for the main programme funding. We're in the process of negotiating the details and hope to sign our first contracts before Christmas.
That's awesome. Roughly how many entities, like companies, research labs, are you possibly funding?
About 26 for the programme.
That's awesome. And they run the gamut of the areas that you said, actuation, sensing, and morphological computing.
That's right. And some of them are also what I call challenge specification creators. So I was keen to get people involved who are not in robotics themselves, but have some problem that they would like robots to solve so that they could work with other creators. Yeah. And I should say, I think I haven't mentioned yet that within robot hardware, the focus of the program is specifically on dexterity. So we're interested in people who have dexterous tasks, like, for example, assembly in manufacturing, the sort of tasks that still have to be done by human beings. What would it take to have a robot be able to do those tasks?
I like that a lot. You want to tell me a bit more about the dexterity challenge and like because I get the importance of it, and I also think that it's an area in robotics where there needs to be a lot of work, and you see a lot of companies working on this. This actually, from my perspective, this seems like a much hotter area, or more money and more investment and more attention all over is going into this area. But I suppose maybe not as much on the hardware. Like you still see 2-finger grippers. But tell me about this area a little bit more.
Right. Well, I think, just as you say, dexterity is just so important because basically anything we would want robots to do for us is going to involve the precise application of forces to objects in the world, which is essentially dexterous manipulation. And, we're seeing robots start to be used, to inspect factories and so on. But I think their use is going to be so limited until they can really manipulate objects in a way comparable to human beings. I mean, not a new point, obviously, as you say, that's why there's so much attention going into it. But my sense is this is an area where the hardware really is going to prove limiting. And the tactile sensing, for example, is going to be really key here. But also the actuation, right? It's just hard to have dexterous fingers if each one is being driven by an electric motor.
Interesting. Yeah. So this is, so what it sounds like to me is this is kind of everything combines around this area of manipulation, because I can see how hardware might be a limit and your sensors might be a limit, and then your ability to design hardware in tandem with how it's being controlled would be a limit, and simulation would be a limit.
Right.
So this is kind of like all of those points, they all focus under manipulation in some sense.
Yeah. Yeah, exactly.
Okay. Yeah, that seems really cool. One thing that's interesting to me is I've talked to a lot of companies that use like the 2-finger grippers or the suction grippers, and they're like, yeah, we tried a bunch of things, but these are just the best working ones kind of thing. Where do you imagine there's a lot of room for improvement? I'm sure there is, but what are things that you're excited about trying, or I don't know, where do you see there being like low-hanging fruit perhaps in this area?
Yeah, I hesitate to describe any fruit as low-hanging in this area. But I think I already mentioned...
Middle-hanging.
Yeah. I already mentioned...
Lowest possible hanging.
Yeah. Assembly tasks. So the sort of things where you're trying to clip something on or maybe stretch and pull over. Right? You may have to handle deformable materials. You may want to, plug in cables in a cable harness. I think all of those, I think it's really going to be challenging to do with a pincer gripper.
Yes.
Disassembly
Are you focusing
as well?
mostly on deformable materials within the manipulation space? Because that is something I don't see any good... I'm not terribly in the space, but I haven't seen any compelling like solutions for deformable objects. Like that's a very hard area for sure.
It's interesting to hear. I wouldn't say we're focusing on it specifically, but it's definitely something we're aiming to address as part of this. For example, taking care that the simulation techniques we develop can handle deformable objects.
Yeah, that's really hard. Like it seems like people work really hard to develop very good simulation models for deformable things, and if they work well, they're very slow. And then that's kind of the opposite of what you need if you want to train things on it. So say you want like a reinforcement learning circuit in there, then that really limits you. Okay.
Yeah.
Well, that's really cool. Okay. So we have those big areas, and we have 26 companies that you're funding, and they're getting
companies,
some part
labs.
What?
They're not all companies, yeah.
Companies and labs, just organizations in general. That you're funding. What's the timeline for this? Are you giving away all of the 50 million right at once? Or is it over several years you start to give more of it? Or how does this all work?
Yeah, we're basically committing it all at once. Each creator has a particular timeline, typically ranging from about 2 to about 4 years for this program. So we'll be spending the money over that period, but we're allocating it now.
That's awesome. Okay. And so with your allocation, how do you, like one of the things that venture capitalists do that I think is kind of clever is they fund a bunch of startups a little bit, or sometimes they'll fund a bunch of startups a little bit. Later rounds that make it different, especially early ones. They'll fund a bunch a little bit, and then they'll reinvest potentially later as traction is being shown with the startups. Will you be doing anything similar, or is it all allocated right away? Or how do you think of it?
We have a few where we are, we've got a couple where we're explicitly allocating exactly. So, we have a go, no go point where we'll decide whether to double down. In most cases, we're making the allocation, up front. I should say all our funding, we remain very involved in the delivery of the projects, and we'll be discussing with creators, whether things are going well, whether we need to pivot, worst case, potentially terminating if it's turning out things are not working well. Which is obviously to be expected, right? It's high risk project. So, you build in, well, let's try this and put a milestone here and see if we reach that point. So depending how things pan out, then if we've decided not to pursue one particular project, that potentially frees up resources to then double down on another project with. But we're somewhat limited in our ability to, we can't have a large amount of follow-on funding within this program because each program has a particular budget. What I will say is, I think looking at DARPA, to go back to what we can learn from that, one of the things that's impressed me about DARPA is how they have a great record of pursuing ideas over a very long time scale, over decades. And I would love to see ARIA doing that. So even though program director's tenure is limited, so I was appointed for initially 3 years, it'll be a maximum of 5 years, and then I'll move on. But maybe another program director will come into this space, and then they can double down. Yeah.
Interesting. Huh. Is that a common thing with DARPA? I mean, I talked with Tim Chung a while ago, who was a DARPA program director. He did the subterranean challenge, a bunch of robots in caves and underground environments. And he is no longer there. So I don't know, maybe their tenure is not that long for this kind of thing.
That's my understanding. That's a key part of the model.
The churn. So you keep getting fresh ideas in. That's pretty cool.
Yeah, I think it's cool.
So you have these companies, they're funded for 2 to 4, I keep saying companies, you have these organizations, they're funded for 2 to 4 years. They're doing these high risk things. Now, you said they're not all in the UK, or it's not a requirement that you fund companies, organizations in the UK. How are you working with global communities or like global organizations that may want to apply for this kind of thing? And what requirements do you have? Like, do they have to move to the UK, or how does it work?
They have to demonstrate UK benefit, which could be through offering something really essential to the programme. We certainly encourage them to consider moving to the UK or setting up an office in the UK. Or
is it anywhere in the UK, or is it like, do you guys have a hub in one location?
No, I mean, we have our headquarters in London, but in many ways, I would actually say, because,
space constraints and things.
Space constraints, or just like, geographic diversity. We value diversity of any axes. So if you want to come to the UK, but not London, then that's great, So yeah, it's about UK benefit, not being in any particular place.
Huh. Do you have any, do you have any examples of organizations that you're considering that are not in the UK, and what kind of problem space are they in?
Yeah. So one company I could mention, it's a non-profit, is Basis. It's a non-profit applied research organisation studying intelligence. It's currently in New York, but as following the ARIA funding, which, as I say, we're negotiating, they're planning to set up an office in the UK, and they'll be working with other creators on this co-design, co-optimization challenge.
Okay.
Another example.
That's really cool.
Yeah,
go ahead.
Because another example is a company in Denmark, Pleantix, a startup that's developing electroelastic actuators for soft motion.
Cool.
Yeah. So they'll also be working with UK creators and enabling UK creators to have early access to prototypes.
Very cool. Let's see. So what are some other examples of organizations that you have that are in the negotiations, I suppose? What are some promising ones? I'm sure they're all promising, but what are some, I don't know, just kind of span the space of different organizations you're planning to work with. I'd love to hear some examples.
Yeah. So one is, I could name a small company, DZP Technologies, founded by a materials chemist called Zlatka Stoeva, and they're innovating in printed electronics. So they're looking to create new components for robotics, such as stretchable and flexible electronic components.
Oh, that'd be really nice.
Right, exactly. And if you're trying to build skin on robots, then those kind of components would be handy. So that's a nice example, I think, of one of the things I wanted to do with this program was bring people from outside robotics to work on the problem. And that's a good example, I think. Another one, we've got, say, some academics also working on the co-design problems. So we have Ed Johns at Imperial College London and Nathan Lepora at Bristol are collaborating closely together on that challenge, looking to develop new techniques for optimising robot bodies and control policies, and then bridging the sim to real gap by rapidly prototyping robot manipulators and seeing how closely they performed to what was expected.
Cool.
Yeah, so they'll be working with Basis and with Rika Antonova, who's a researcher at Cambridge. Again, all bringing their different skills and unique talents to bear on different aspects of this challenge.
Mhm.
Another company I could mention is Wave Drives. So that's a small company near Bristol, and they're developing a really interesting non-contact magnetic transmission linear actuator.
That's going to take me a minute to unpack.
Yeah.
Non-contact. What is it? Say it again.
So it's a linear actuator. Think like a piston sliding in and out, but it's not actually in contact with the cylinder around it.
Oh, so it uses magnets to do that?
Exactly.
That's what you were saying?
Yeah, that's right. So there aren't... The advantage of that then is there isn't friction, there isn't wear, there isn't a need for lubrication. So it's... Yeah.
Interesting. Sounds finicky to me. But it could be very, very useful to have. Yeah, no friction and all that.
Exactly. They'd be developing their technology in areas like aerospace and prosthetics. And obviously for this program, they're developing it for robot dexterity specifically.
What a cool thing. I can imagine in sci-fi movies and things when you have like a floating arm that you can control for all this thing because magnets are holding it up. Like that kind of thing would be super, super cool. I wonder if we'll ever get to something like that. Okay.
Yeah.
These are great. Any other ones you want to mention?
Well, you were talking about magnets and floating. It reminded me of a project that's actually not part of the Dexterity program itself, but part of our seed funding. So another thing we do at ARIA is that within the wider opportunity space, so in my case, robot hardware, we can make small seed awards to explore really interesting ideas. And one of the seed awards we made is, again, interesting to bring people from outside robotics. So this is a chap called Christopher Wall, who's actually a cardiologist. Yeah, and he's founded a company called Cardiology Devices, and he's looking at developing a ventricular assist device to aid patients with heart failure. But as part of
steer
that,
a catheter or what kind of things?
No, I don't believe so. I think just to aid the blood flow, although don't quiz me too closely. Yeah, exactly.
Cool.
So based on that, he got interested in motors, right? Because he needs a motor for that purpose. And so he applied for seed funding for ARIA to develop a bearingless motor. So, rather than resting on bearings, the motor is essentially suspended in a magnetic field. So again, it's a rotary motor this time, but the same idea that you don't have the wear. Yeah.
I can't wait till that stuff works. Yeah, no friction, no wear.
Right, exactly.
Bearings not seizing up at some point. That will be so wonderful.
Exactly.
Gosh, we're heading into the future quickly, it seems.
And so you can see this strategy there that we've got a kind of portfolio of actuation techniques, some of which are sort of different forms of motors and some of which are completely different technologies, like the electroactive actuators or Hazel actuators. We're also funding a US company called Artemis that's developing Hazel, hydraulically amplified soft electrostatic actuators. So we're kind of spreading our bets amongst a lot of different actuation technologies and trying to really bring them forward and ensure roboticists in the future have more components to choose from.
That would be awesome. So one of the things that's a big bottleneck, so this sounds like it's very wonderful and future focused for this. I view a massive bottleneck being like you come up with an amazing way to do motors that are frictionless, say. It's still like manufacturing capacity is a tremendous difficulty. Like a lot of the research stuff, like maybe it'll work once, but it's like way too expensive to manufacture, or it's just hard to manufacture, especially with like aging demographics and all sorts of like everything getting more expensive in general. What do you have any, are you guys, maybe it's out of focus, but what are your thoughts around potentially trying to help the manufacturing bottleneck that some of these technologies may encounter?
Yeah, you're right. It's definitely something we need to think about. I think, to be honest, that probably, when you really get close to manufacturing at scale, that probably tends to require more resources than we're likely to be able to make available.
Probably true.
Right. So we would be aiming to get to the point where it's attractive enough for other people to invest.
Push it. Yeah.
But we're definitely thinking about how can we demonstrate the feasibility of that. Yeah. So we're working, for example, with the Manufacturing Technology Centre in the UK, which basically exists for this kind of reason, to try and help companies figure out how to manufacture what they need.
Okay. I'm pretty ignorant. How significant, like, does the UK do a lot of manufacturing? Or does it, I don't know much, I suppose.
Yeah, no, we do. We have quite a strong manufacturing sector, actually. Yeah.
Awesome. Okay. So those are all great examples of different companies and initiatives. It's cool to hear that you guys, I mean, you're leveraging and thinking about how it goes once it gets out of kind of the research and early stages. And then are any of the technologies more mature, or are they all very high risk very early?
They vary. So, yeah, they're not all very high risk. The Artemis, the company making Hazel actuators, they already have some products out. And the work they're doing is, I would say, towards the close to market end. Then we have Tawfiq Hassan at Cambridge is developing an electronic skin, and that's very early. So that's at Cambridge University, and that's very lab-based. So, we span the range.
Hell yeah. Okay. So for all of this, how do you measure success? Like, how do you know if the batch of organizations has gone well, or how can we see if it's the whole initiative was a success? And also, I'm assuming then we use that idea of success to justify future programs and continuing in this vein, maybe, or how do you think about success?
Yeah, that's a really tough one, right? It's famously hard to assess success. I think it becomes clearer with hindsight. So I think the thing we say about ARIA is that we should be able, in a generation, to look back and it just be completely obvious how ARIA-funded research has transformed society and benefited the UK. And, again, going back to DARPA, but you look at their sort of, you can point to the internet or mRNA vaccines and so on. In the short term, obviously, we're looking for signals that we're heading in that kind of direction. So I guess it's, demonstrating new capabilities, new products that we can say, you could see that the ARIA funding was critical in getting them there.
Awesome. Yeah, it is a hard thing to measure with all these, especially in the really short term. But I think it'd be really cool to see some major things you can point to in a generation and this kind of thing.
Absolutely. And in the shorter term, I think things just like new communities, new conversations, potentially new interest in robotic hardware.
Definitely. Yeah, I think one of the things that's really exciting about what you're doing to me is that you're getting people that are not involved in robotics traditionally into this. And so what it's doing, in my opinion, or from my perspective, would be getting them exposed to this world that I think is going to be very impactful in the future. And so we can have more hands helping out in robotics in general from all of this.
Right. Yeah, exactly.
So you mentioned at the beginning that the ARIA, is ARIA the full program, or is it, like you mentioned, it started in 2023, this initiative. Is it guaranteed to continue? Like, is it a commitment from the government to continue for decades? Like you're saying, measure in a generation, or how are we thinking about the future with all this?
So ARIA was set up for 10 years by that initial Act of Parliament. And then it'll be reviewed. Obviously, we're hoping that by that 10-year point, there will be enough to point to that the government will be like, this is really working out.
Make
Excellent.
it bigger.
Make it bigger. Make them carry on. But at this point, it's that 10-year commitment.
Okay. Let's see. And then so thinking about the listener, what do you hope they take away from this? Or is there any should they join the next batch, or what are kind of calls to action for anyone who's listening to this?
That's a great point. I think part of what I would like them to take away is that they've now heard about ARIA, which maybe they hadn't in the past, and maybe go on our website and sign up for updates. We have, as I mentioned, 7 programs running at the moment. Some calls are closed, some are open. We're also recruiting our second cohort of program directors who will be starting early in the new year. So there'll be a second round of programs coming out. So, if you sign up for updates, you'll find out what those are and, potentially want to apply.
Yeah, I'll put a link if it's out when we publish this in the not so distant future. I'll put a link so that people can find it more easily to sign up, but then also maybe to the submission, because that'd be really exciting to have more people in the innovation space in general, I think.
That'd be great. And I think for my program specifically, I would say, please get back to me with any feedback about what you've heard. If you have any hardware needs, if you're excited about any of the work that I'm funding that I've mentioned, please get in touch. We aim to have some workshops and dissemination activities to talk to people about what we're doing. And obviously, we'll be super keen to get any new components or actuators or sensors or whatever out and tried out and tested by people who have interest in them. So, please get in touch if that's you.
Yeah, that would be awesome. Do you have so from your perspective, 3 years or 5 years when your tenure is over for the ARIA program, what would be success in your opinion? What do you hope you've gotten to in the time?
Great question. I think I'm really hoping that the creators that I'm funding are going to achieve something amazing. And I'll just be so excited if even half of what they've proposed comes off.
Oh, yeah.
Yeah.
Yeah, that would be awesome.
I think if we could have demonstrated,
go ahead.
If we could demonstrate the value of the co-design approach, demonstrate that, yes, we have actually reached the point where simulation is powerful enough that this is an entirely new way of designing robots and controlling them, I think that would be amazing. If robots are going around with tactile skins that were developed, funded by ARIA, that would be awesome.
Mm-hmm. Yeah, skins would be a big value add, I think, especially putting robots in the home and things like this. And simulation, I feel like if you made significant contributions to the simulation space, that would open up so much. I think simulation is a real bottleneck, in my opinion.
Interesting.
So anyways, Jenny, it was wonderful talking with you, and Thank you for telling me about the ARIA program.
Great. Thank you. It's been an absolute pleasure.
All right. Bye, everyone. That's all for my conversation with Jenny Reed. I hope you enjoyed, and see you next time.